Hello and welcome to all of your students. This is your teacher Sudipta Nath, and today again I am returned back with kinematics and theory of machine, subject code PCME 503 module 1 and part 6. Today's video I am going to discuss about the numerical problems on degree of freedom and related. So it will be a bit long video. Stay tuned. Now, degree of freedom and mobility of a mechanism is the minimum number of independent parameters required to specify the location of every link within mechanism. The mobility of mechanism defines the number of degree of freedom. So obviously the Grubler's criteria comes along with that. Now, according to Grubler's criteria, degree of freedom of a system that is equal to 3 into n minus 1 minus 2j minus h, where n is the number of links in the mechanism, j is the number of lower pairs, l is the number of loops, and h is the number of higher pairs, where j is indicated by, if it is not available directly, then indirectly it can be available by n plus l minus 1. Now let us directly go to the case study of degree of freedom on numerical problems, which you are waiting for, that I know. So first case, it is a classic slider crank mechanism. Over here you can see link number 1 is a crank, link number 2 is a follower, and link number 3 it is a slider block which is supported on link number 4. So degree of freedom, Grubler's criteria, the formula that we know, 3 into n minus 1 minus 2j minus h. So over here given that n equal to 4, j equal to 4, and higher pair h that is equal to 0. So the degree of freedom, calculate, and found out that 3 into 4 minus 1 minus 2 into 4 minus 0, that is 1 that we are getting. Have you understood? Then we are proceeding towards the next particular numerical problem. So this is the second problem, where you can see that there are 3 different triangular shaped links, that is link number 2, link number 3, and link number 4. Link number 1 over here, it is a fixed link. Link number 7, 8, 5 and 6, they are 2 simple linear link. So again we have found out that the number of links over here present, that is 8. We have to find out number of pairs. So we have calculated and found out that is 10. There is no higher pair. Now can you find out what is the degree of freedom of this system? If you want to do it by yourself, then pause the video over here and try to solve it by yourself. Otherwise, no problem, you can proceed throughout. So the degree of freedom over here, according to Grubler's criteria, that is 3 into 8 minus 1 minus 2 into 10 minus 0. So over here we are getting that is equal to 1 once again. Third problem. Here the situation is a bit different. Here we have incorporated one slider crank mechanism between 1 and 4 that you can see. Okay, so the calculated value of the number of links is 8, the number of pairs, that is 10. It is not given data, we have to find it out, and higher pair is not present because sliding pair, because there is surface to surface contact, so it is not a higher pair, it is again a lower pair. Please remember that when there is a point to point contact, then it is considered as higher pair. Otherwise, if it is a surface to surface contact, then it is considered as lower pair. Can you solve this problem? If you want to try, then pause this video over here and proceed forward. Otherwise, no problem, you can go through. So the degree of freedom, 3 into 8 minus 1 minus 2 into 10 minus 0. So obviously again we are getting the net degree of freedom of this system equal to 1. The fourth problem over here, it is a weird kind of mechanism, bit complicated looks, but actually it is very simple, because 3 triangular shaped link and the other are simple linear link. So over here, according to Grubler's criteria, we are getting the number of links equal to 8 and the joints are 10. There is no such higher pair. If you simply solve it, you will get the answer, that is the degree of freedom equal to 1. In the next case, in the next problem, we are getting this type of mechanism. Perhaps you have seen this type of mechanism. Closely observe that over here link number 1, which is a fixed link, and link number 4 that consists of several roller or ball bearing like link. So they are not exactly same, because link 4 has got movability. It is not a fixed link, whereas link 1 is a fixed link. So higher pair is present over link number 4. So degree of freedom, according to the Grubler's criteria, we are getting h equal to 1. The number of links are 14, that already has been counted. We have to find out what are the number of binary pairs. So that we have binary or ternary or whatever. The pairs of grade 1 that we have found out, that is 8, and that is lower pair, and higher pair, that is equal to 1. So by solving this, we are getting degree of freedom of the system equal to 2. This is a very unique criteria. So please remember this. We proceed forward to the next problem, that is problem number 6. So here we are getting that in this type of mechanism, it is a very simple mechanism. There are several binary and ternary pairs are present. So 4 ternary and the others are binary links. So degree of freedom over here, in absence of any higher pair, is equal to 1 once again. In problem number 7, you see that there is also a curved surface which is in contact with a linear surface. So higher pair is present in this case. So h will be 1 in this situation also. So according to Grubler's criteria, we are getting that number of binary links equal to 7, then pair of degree 1 equal to 8, and that is lower pair, and higher pair equal to 1. So solving this, we are getting degree of freedom of this system equal to 1. Now we proceed to the last situation, that is case 8. So there are 3 different criteria of this particular problem. Perhaps you have gone through. It is a kind of cam follower system. Now there are 3 possible situations of this system, that is follower will have rolling and sliding both the motion. So basically there is higher pair, that you can see a curved surface is in contact with the curved surface, and there is a point contact obviously. So degree of freedom according to Grubler's criteria, we are getting lower pair equal to 3, higher pair equal to 1, where number of links are 4. So by calculating all this criteria, we are getting degree of freedom equal to 2. If you have understood this, then it's okay. Otherwise you roll back and just go through this video once again to understand that what actually is going on, because situation 2 will be different in case number 8. So situation 2, if the link 3 and 4 constitutes one link, that is there is no rotary motion of link number 3, if that phenomena is going on, still it is considered as higher pair. And in this situation we are getting number of links equal to 3, whereas binary pair equal to or lower pair equal to 2, or equivalent lower pair equal to 2 and higher pair equal to 1. So by solving we will get degree of freedom equal to 1 in this particular situation. Have you understood this? Otherwise you just roll back and just go through this video once again. Okay, so the last case or last situation where the contact between the cam and the follower is pure rolling, then obviously the higher pair will be present. So just go through this figure once again and try to understand the cam and follower. There is pure rolling action, there is no sliding, but rolling is going on. So according to Grubler's criteria, n should be 4, lower pair equal to 4, and higher pair is not present in this situation. Try to understand, the contact between the cam and follower is pure rolling, therefore there is no such higher pair is considered. So under this situation, degree of freedom equal to 1. That's all for today's class. That's all for today's session. Hope you have enjoyed it. Hope it is helpful and beneficial for you. We'll meet soon in a new video very soon. Till then, goodbye.